Okay, this is sample problem 14.1, the first problem in the chapter. So what we're going to do here is we're going to write the rate expressions for each of the following reactions. Now, what you want to do with the terminology here is be careful. There's a similar type of worded question, which is called find the rate law for each of the following. We don't want to do the rate law here. We want to do rate expressions. So rate expressions are very simple. All you do is you write that the speed of a reaction, remember rate is speed, the rate of a reaction is equal to the change in the concentration. Delta is change in. You've seen that in Chem 11, change in temperature, change in volume. For concentration, we're going to use bracket notation, so we use square brackets here. And you can write the rate expression for any reactant or any product. So I'm going to put the first one, which is the iodide. And the rate is the change in the concentration divided by the change in time, delta T for time. Okay? So just like the speed of running is your change in position divided by change in time, the change in the rate, or I should say the change in the concentration divided by the change in time is the rate of the reaction. Now, we want the rate to be positive. So if it's a reactant, you put a negative in front of it. And the reason for that is that the change in the concentration of a reactant is negative. It starts at a high concentration and goes down to a low concentration. That's how it's changing over time. So that's a negative change. So to make it positive, if you have a negative and you want to make it a positive, what do? You multiply it by -1. So that's what we're doing there. We're putting a negative in front of it. So the same is true for the second reactant, OCl, which is hypochlorite. We can write the rate of reaction as the change in the concentration of hypochlorite over the change in time. But again, since it's a reactant, we put a negative in front of it. And that is the expression for both of the reactants. But we can also write it in terms of the products, either way, reactants or products. So that means the rate is also equal to the change in the concentration of chloride divided by the change in time. However, this is a product, and a product increases in concentration over time. So if it's already increasing, that's a positive change. So we don't need to put a negative in front of that one. And the same is true for the second product, hypoiodite. Change in the concentration of hypoiodite divided by the change in time, and we don't need a negative for that one either, again, because it's a product, so it's already a positive number. The reason we put the negative for the reactants is because we want them to be positive. We do not want to say the rate is negative something. We want to say the rate is positive something. Okay? So we can do the second one, which is part B. In part B, it's a little different here because notice the coefficients are not 1. So what happens is when the coefficients are not 1, we want to take that into account. And the way that's done is by writing it just like we would. So I'm going to do the first one, which is the ozone, O3. Change in the concentration of O3 over change in time. Remember, it's a reactant, right? And we put a negative, it's a reactant. There's a 2 as a coefficient, so what you do is you divide it by that coefficient. You take whatever the coefficient is, in this case it's a 2, and you put it down in the denominator. What that does is it divides the change in concentration by 2 so that it's equal to the rate. Same thing with the product. Product is 3O2, so change in concentration of O2. Change in time. It's a product, so we are not going to put a negative in front of it, and we're going to divide that by 3. Okay? Part C. This one's just a little bit longer. It's got 2 reactants and 2 products, but it's still the same procedure. So let's try the first one. I'm going to write R for rate is equal to change in concentration. Let's do the first reactant, NH3, ammonia. Change in concentration over change in time. That's the definition of a rate, the change in concentration over time. However, if it's a reactant, we put a negative in front of it to make it positive, and then we divide that by the coefficient. So we just divide it by 4. Do the second reactant, change in concentration of O2. Change in time. It's a reactant, so we put a negative. There's a 5 in front of it, so we put a 5. That's not an S, that's a 5. Do the products, NO. So change in concentration of NO. Change in time, look at the coefficients. There's a 4 there, so we divide it by 4. It's a product, so we leave it as a positive. And then finally, the last one, change in concentration of H2O. Divided by change in time, it's a product, so no negative, divided by 6. Now, I will point out that sometimes if you're doing a problem and they're talking about gases, they may want you to do it in terms of pressures. P. So if I were going to do one of these, I'm going to try the last one, because in the last one, everything is a gas. So I'm going to write that the rate is equal to, again, P for pressure of ammonia. See how I wrote that? And then change in time? Change in the pressure of NH3. And then again, you've got a 4 is the coefficient, so we put that down there, and then we also want the negative because it's a reactant. Same thing for the second reactant, which is O2, negative, change in, actually, you don't have to put brackets even, you could just say P, delta P of O2 divided by 5 delta T. Okay? So I'm going to actually erase the bracket because that's actually inappropriate use of bracket notation. The bracket notation is meant to mean concentration, not pressure. So we don't need to have it in there. Okay? So just change in pressure of ammonia, change in pressure of O2. We can do the products as well. We got NO, it's a gas, so change in the pressure of NO divided by delta T. There is a coefficient of 4 in front of it, so we put that there. No negative because it's a product. And then finally, change in the pressure of H2O. There's a 6 as a coefficient, so 6 delta T. And then finally, you don't need to have a negative for that one as well. Okay? So typically these are done as concentration changes, but they can also be done in terms of pressure changes if they're gases.